So hello guys, welcome to Backbencher Studies channel. In the last video, we discussed how we can plot the polar plot, and we already saw some basic parameters and basic principles of complex numbers and the analysis of complex numbers with respect to the two-dimensional Z plane. And we also saw the procedure for finding the polar plot is nothing but we need to find out 4 points, four important points. They are omega equal to 0 and omega equal to infinite, and at what point the polar plot is actually intersecting the imaginary and real axis respectively. So in this tutorial we are going to solve a problem based on plotting or drawing the polar plot. So let us start our session. So let us start with our session with this question over here. So draw the polar plot of the following transfer function. So we are given with a transfer function g of s equal to s cube by s plus 1 into s plus 2. So let us start doing that. So our first step is to find out the frequency response based on the transfer function. So to find out the frequency response of the system, we need to replace s equal to j omega in our transfer function equation. So step 1 is to find out the frequency response. So if we do that, if we substitute s equal to j omega over here, we have j omega whole cube into 1 plus j omega into 2 plus j omega over here. So if we find out the magnitude of this corresponding frequency response, so we can say that the magnitude will be, so if we assume that this is a complex number and the denominator as a complex number, then the magnitude of these z1 by z2 would be the magnitude of individual complex numbers divided. So this is how we can find out the magnitude. So we have omega cube magnitude in the numerator, and we have square root of 1 square plus omega square for this corresponding complex number, and we have square root of 2 square plus omega square for this corresponding complex number. So this is how we can find out the magnitude of our frequency response, and we need to find out the phase angle of this frequency response. So to do that, we have three poles which are at imaginary axis, which is positive imaginary axis. So positive imaginary axis corresponds to the anti-clockwise angle of 90 degrees. So we have three of them, so we can write the angle in the numerator as positive because it is in the numerator, and the denominator angle would be subtracted from the numerator angle in order to find out the angle of division of complex numbers. So we have three repeated poles, each of having an angle of 90 degrees. So we can add the angles, so thereby giving us 270, the angle of numerator corresponding numerator's angle. And if we do the angle of this denominator polynomial, we have tan inverse of omega in this, and we have tan inverse of omega by 2 for this corresponding complex number. So this is how we can find out the transfer function, and we can express the transfer function in terms of the magnitude and phase. So let us find out what would be the corresponding magnitude and phase at omega equal to 0 and omega equal to infinite. So if we substitute omega equal to 0 in this corresponding magnitude, then we can have the magnitude of this transfer function of this frequency response would be 0. And if we find out the angle, if we substitute omega equal to 0, we have 270 degrees as our phase. So we found out at omega equal to 0 our magnitude is 0 comma angle of 270, And if we find out similarly for omega equal to infinite, if we substitute omega equal to infinite over here, then we can have infinite magnitude, and if we substitute infinite over here, then we can have 90 degrees of angle. So we are done with two of our points for polar plot, that is the angle, the magnitude and angle of the frequency response at omega equal to 0 and omega equal to infinite. So if we plot them, so this is our complex jet plane with real part being plotted in the x-axis and imaginary parts being plotted in y-axis, and we have the corresponding angles notation over here. So at omega equal to 0, what we have is 0 magnitude with 270 degrees angle. So this is 270 degrees angle. Remember, the magnitude is nothing but distance from the origin. So if we have 0 distance from the origin, our point should lie at the origin itself because it is having 0 distance. So if we plot that, this is the point at which we have the omega equal to 0, the corresponding magnitude and corresponding phase. So we are we are plotting the magnitude and phase of this corresponding transfer function over here. So we are having at omega equal to infinite, we are having infinite magnitude and 90 degrees over here. So this is the point at which we are having the omega equal to 0, and this would be the point at which, so we have the infinite magnitude, the distance from the origin infinite, and we have the angle plus 90 degrees at omega equal to infinite. So essentially we found out that the 2 points which are at omega equal to 0 and omega equal to infinite. So let us find out the other 2 points, that is the intersection with respect to the real axis and imaginary axis as well. So these are the corresponding points. So moving on to step 3, we need to find out the intersection with respect to imaginary and real axis. To find out that, we need to write the complex number in terms of the real part and imaginary part. So if we do the rationalization to, in order to write this complex number in terms of the real and imaginary parts, what we need is rationalization, that is we need to multiply with the complex conjugate of the denominators. So if we do that, then we are having this corresponding equation over here. If we simplify that further, if we multiply these three polynomials in this numerator, then what we have is this kind of expression over here. So the real part of this frequency response is minus 3 omega power 4 divided by 1 plus omega square into 4 plus omega square. So, and if the imaginary part being this one, which is which we derived over here. So if we equate this real part equal to 0, then we can have the omega equal to 0. So that omega equal to 0 point, we already discussed that magnitude, we already derived that magnitude, and we are left with the equating of imaginary part equal to 0. So if we equate imaginary part of this frequency response g to 0, then we can find out the intersection with real axis. So if we do that, we have the solution frequency of omega equal to square root of 2. So if we substitute that square omega equal to square root of 2 in our magnitude equation, we can have 0.66 magnitude if we substitute omega equal to square root of 2 in this equation. And if we find out the angle of in at omega equal to square root of 2, we can find out that it is 180 degrees. So we are done with our finding out our points. So we have our point at omega equal to 0 and our point at omega equal to infinite with corresponding magnitude as infinite, because the distance from that point to origin is infinite, and it is at an angle of plus 90 degrees measured in anti-clockwise direction. And we cannot find the intersection with imaginary axis, because that is what we are getting as omega equal to 0, the solution frequency, which is nothing but what we already found out. And this is the point at omega equal to square root of 2. By this we obtained by equating the imaginary part of this frequency response to 0. So imaginary part equal to 0, that what would that mean is nothing but the intersection with the real axis of polar plot. So if we plot, so based on increasing omega frequency, we have omega equal to 0 and it is going towards 270 degrees in this way, and it should touch the 180 degrees at omega equal to square root of 2, and at omega equal to infinite it should reach in this way. So if we plot that, this is the curve we have, and this is the direction of this polar plot. By increasing the magnitude of omega, we are dealing with this kind of polar plot over here. So this is the polar plot. This is how we can plot the polar plot for a given transfer function, open loop transfer function. So that's it for today, guys. If you have learned something new in this presentation, please give it a thumbs up, and if you are new to our channel, please do subscribe to our channel for more interesting and for more educational content. So that's it for today, guys. Thank you for your amazing time.